Hello, this video is part of a series of videos on making CAM in the Bechtel Center at Purdue. Last video, we covered making our first setup, currently shown right down here. Now, in this video, we're going to cover probing and the simulation engine that's built into Fusion. So, probing is important because in the CAM world, in the Fusion world, we can make things basically as precise as we want them to. We can say that this part is going to be exactly centered. And now in the real world, that's kind of hard to do. Can you send, if you give me a chunk of stock, I probably couldn't center in the vise to 1/100th of an inch, 1,000th of an inch. That's gonna be pretty hard. But if we don't do that, then all of our features will be shifted over by that little amount. And that's not a good thing. In order to fix that, we do something called probing, where we put it in pretty close to the correct position, and the machine goes and brings in a probe, and it goes and says, actually the whole stock is shifted over 0.01 inches. So I'm just going to shift everything else over 0.01 inches and then just go off of that. Great. In order to add our first probing operation, we can go to Setup, Probe WCS. And then you can go, and then at this point, I'd like to explain a brief thing about Fusion's operations. So every operation you add in Fusion, whether it's a probing or a facing or a 3D adaptive, we'll have a couple of tabs up here. The first tab is the tool. This will determine which tool you're using and how fast that tool is moving and other things like that. Next tab is geometry. This is telling it what part of the model you actually want to do stuff to. In the case of probing, it's going to be, hey, which face do you want me to probe off of? If you're doing something like facing, it'll be, hey, which parts of the model do you want me to face? And stuff like that. Heights is going to be a couple of settings that it's going to say, hey, here's where it's safe to be above the stock, and you're above the stock, you're not going to crash into anything. You can move as fast as you'd like. And then there's somewhere like, okay, so start machining at the top here, and then go down to here. Heights manages all of that. And the last tab, we have the WCS. In other tabs, this is replaced with a passes and a linking tab. But because probing is a little bit weird, it doesn't have that. Cool, let's just go through and set up our probe for our tool. We can go down to, on this side, I'm using the VF2 and VF4, so I'm going to go down here, and I'm going to select our probe standard. I'm going to select this, and then select, and there you go. You can leave these and the default preset for probing. Next thing is our geometry. In this case, I want to probe the top face first. Like this. You see that it defaults to probing X and Y first before probing Z. Actually, in this operation doesn't even probe Z. We're going to make a separate operation for that. And I like to probe Z first. And the reason for that is that if our X and Y offset is wrong, let's say that our part is shifted too far to the left, then our X and Y probing is going to fail. But our Z probing is probably still going to work just fine, because it doesn't care whether it touches down in the middle here or off to the right here. It's still going to touch down just fine. But if our Z height is wrong, if the stock is, say, too tall, then our XY probing might crash into the stock, and that's not a good thing. Or if our stock is too short, it might just miss it entirely. So basically, I like to do Z because there's less things that can go wrong. Then in heights, these look good heights. These look like good heights. And then in WCS, we need to click Override Driving WCS and change it to 2. And if you ever forget, there's a nice large red text right here. This is Probe WCS Override, should be number 2. Great, now I can press OK. And then we can repeat this step for XY probing. And you saw that it had already selected the same tool as before, and that's because it just tried to pull the tool from the previous operation. Cool. In this case, we would like to keep our XY rectangle. XY rectangular boss, so just probing X and Y. Height is fine. You'll see here the probing surface top with bottom height is now moved down very slightly. And that's that, and you can see that here, because if it wasn't moved down at all, then it would just skim over the top of the part and not actually hit it, which is not what we want. And then once again, we can use override driving WCS and change this to 2. Cool. At this point, this is a quick tutorial on how to set up probing manually. However, we do also have a probe template. And the way you can access that is by right-clicking on your setup and clicking Create from Template, XYZ probing. See that it creates Z probing and then XY probing in that order. Now, the important thing about this is that it selects your tool automatically. It selects just like your surface because it doesn't know what you're doing, but it sets your heights and your WCS already appropriately. So you can use this, or you can use the manual method of probe creation. Take your choice. Now, I'd like to show you the simulation engine that's built into Fusion. To use it, select your setup, and then go into Actions, Simulate. Cool. A couple of notes about this. Down here, we have our playback controls and our speed controls. This button is our start simulation. This is also our speed slider. This is very fast. This is moderately fast. This is stopped in the center. This is moderately fast, but time is going backwards. And this time is going backwards extremely fast. I'm going to set it to a pretty slow speed and then show you the rest of the simulation. The important things are, this is the tool. It goes and either shows you the entire tool or just the tip of the tool. Usually want the entire tool displayed so that if the holder of the tool is set to collide with something, you can see that it's going to do that. Next thing is this tool path, and it's going to show the path of the tool. I prefer to leave it off, but some people prefer to leave it on, so take your pick and see which one you like more. Next thing is the stock. This one, I would highly, highly recommend your stock polarization be set to comparison. And the reason for that is that comparison will go and show you where you have more material you need to take away, you're already at the correct size, or you've taken away too much material. In this case, you can see this green band along the bottom. That means that that's good, that the material is already the right size. But up here up top, you'll see that there's blue material. That means I need to go and do more machining. I need to take away more material. And then finally, you shouldn't really ever see this, but if you ever see this red, it means you've taken away too much material, and you probably need to go back and figure out why. This accuracy slider will go and determine how accurately Fusion simulates your stock. The lower the accuracy, the better the simulation runs, but also the worse some things, especially holes, will look. So in general, try and have it as high as you can, that while Fusion can still run at a reasonable pace. And then over here, we have stop on collision. This will just mean that if it collides, if something collides with something else, Fusion will say, hey, something's colliding, and then stop the simulation. If you have this unticked, Fusion will say, hey, something's colliding, and then just keep on going. And that's not what you need. You want it to actually stop and show that, hey, there's a collision. You need to go and actually investigate why. Because collisions are not good. Cool. We can start by pressing Start Simulation. See that this is the Z probing, so it's going to come down. It's going to touch off the top of the material. See that the tool turned red, the simulation stopped, we have a collision. So Fusion gets a little bit antsy when probing, because by definition, a probe needs to collide with the material. Otherwise, it can't know where the material is, and so it can't do its job. However, it is always a good idea to check whether this is just a Fusion being antsy issue, or if this is an actual collision. And the best way to check is to look at the probe like this. You can see that the probe is just barely touching the top of the stock. It's not actually going in and gouging a deep hole. That's good. That means it's probably just Fusion being antsy. That's fine. You can start simulation again and continue on. Cool. Now that first operation finished, and we're going to go into our second one. And now once again, we have a collision. So let's look at it from the side. And we can see that, once again, we're just barely touching. So we can safely say that this is Fusion being antsy. Cool. In the simulation, you can see the exact path the tool will take. And when you actually start machining, you can see what the final part should look like after you're done. This is very helpful for making sure that you don't miss any spots and that you're doing things in the best possible operation order and that you're not colliding with anything. Excellent. Thank you for watching this video and learning about the probing and the simulation engines. Have a good day.